Hi, I'm Ethan Kwan, and today I'm going to be showing you, telling you about pendulums. And a pendulum is a type of simple harmonic oscillator. Okay, so first, actually, if we delete this guy here, if we get rid of this guy, a pendulum is a simple harmonic oscillator. Now, we know what a simple harmonic oscillator is. It is an object that goes back and forth, back and forth. So, there we go. So it'll go from here to here to here to here to here, and so on, right? Okay. So we know the formula for any simple harmonic oscillator. It's x as a function of time is equal to the amplitude times the cosine of 2 pi over t times time, or t is period. So period times time. Okay, so that is the equation for any simple harmonic oscillator. What is the equation for a pendulum? Well, a pendulum is not going to be x, it's going to be theta. Theta is this angle right here. So this is theta. Okay? So, that angle right there. So, it's going to be theta as a function of t. T. Right? Is equal to the amplitude times the cosine. Cos. Times 2 pi period t. Right? Okay, so a great question to ask here is what does the period depend on? What does the period depend on? Well, you might be clever and you might say, well, maybe the mass. If you think the mass increases the period or decreases the period, well, some of you might say, okay, so if mass goes up, it has the inertia. It's the inertia on this ball will go up, which means it's harder to move around. So that means maybe the period should go up. But some of you might say, hold on a minute. If the mass is greater, the gravitational force on this ball must be greater. So that means it should go faster and faster and faster, so maybe the period should decrease. Now, both of you are right, and those two factors, the gravitational increase and the inertia increase, cancel out perfectly. It's kind of like 1 over 2. If this is g and this is inertia, it's kind of the same thing as multiplying this by 2, or 2 over 1. Right? Okay. So this, yeah. Cancel. No. Okay, anyway. So those two effects cancel out perfectly. So then what does the period depend on if it's not the mass? Well, I'll just give you the equation. The equation for the period for a simple harmonic oscillator is period is equal to 2 pi times the square root of length of the pendulum. So length would be this guy here, right there. So length of the pendulum divided by the gravitational constant. Now, this 2 pi is just a constant. Length is the length of the string on the pendulum, and g is gravity. Now, you might be clever, and you might say, well, wait a minute. Copy this. Wait. 1 sec. Copy, paste. Okay, so you might say, well, hold on a minute, wait, but isn't the equation for mass on a spring almost the same? So instead of length up here, it would be the gravitational. It would be the mass, right? And down here is going to be the spring constant, K, right? So aren't these equations too similar to be a coincidence? You're right. These two equations are almost exactly the same, right? That's because, well, these two have a relation. Look, this is M, this is L, right? Each of these increase the inertia of the equation, of the pendulum or the mass, right? So if for this guy, if it's a hotter mass, then it will have more inertia, so it'll be harder to move around. Same thing with the length. It actually increases the inertia if you have a longer string. If you have a longer string, you have a greater length, so that means that the inertia increases, which means it goes faster, right? No, it goes slower, sorry. So if the length increases, the period increases. Same thing with the K and G. These are both constants, right? So if we increase the K, then that's the spring constant. It'll contract and stretch faster. Same thing with G. So this is inertia. It's based on inertia, and this one is based on mass. Kind of. Okay, so if you decrease the K or the spring constant, it'll go up. If you decrease the G or gravity, it will go up. So that is how pendulums work, and that's basically an intuition on how pendulums work. That was a very short video. Thank you for watching. See what how to do stuff and see you next time. Bye.